solubility curve?
Solubility.
Okay, no problem. It is okay. So, thank you very much, and thank you for attending this class. I know we are still waiting for the rest, but as you wait for the rest, you can just continue. The good thing is it is being recorded. So they will watch it later on, or they can stream it later on. So we have talked about salts. So we started about with salts from Form 1. That was the reaction acids basis. And then we came to the salts. Actually, now the Form 2 work. Now, in Form 2, we talked about solubility of salts. We were not specific on the type of salt. What we're talking about in Form 2 is the universal name. For example, we're saying how soluble is the chloride. We didn't go to maybe sodium chloride, but we said all chlorides, for example, are soluble except this and this. All sulfates are soluble except this and this. All nitrates are soluble. All carbonates are insoluble. Those ones, we were talking about the universal name of a salt. Now, in Form 4, because actually the salt is a continuation. So in Form 4, we go now to the specific. We are talking about a specific salt. We are talking about potassium nitrate itself, kama imejisimamia. We talk about sodium chloride, kama imejisimamia. Magnesium sulfate, even. That one now is something that we are coming to do. Yeah. Now, the word solubility, everybody knows the meaning of solubility. Actually, in English, they will say solubility is when you add uh, a solid, which is the solid part, into a liquid and then it disappears or it forms a solution. That one is solubility in English and the other subjects. Now, when you come to chemistry, actually it becomes very specific. Solubility in chemistry is very specific and we're going to tackle it very slowly. Now, since you are the only one, so we'll be discussing together. So there's no problem. So we can even start from now. This one is the discussion that we are going. This one was a discussion that was done, and we want to explain it in English before we go to the chemistry part of it. So we said it is a limit of how much a solute can be dissolved in a solvent. Now remember, I'll be writing something. And remember, what I just mentioned is that the solute is the solid. So let us. I'll be putting S for solid, and then the solvent is the liquid. So I'll just we'll discuss that and then we mention, we change it so that we see. So it is a limit of how much of a solid or how much a solid can be dissolved in a liquid. So the solid is the salt, which is the solid, and then can be dissolved in a solvent. A solvent is any liquid, even milk can be here. But the most important thing here is the temperature. So temperature, at what particular temperature? So that temperature is very important. So solute, solid. I think I had mentioned it previously, but we just repeat it for the sake. So solute is the solid. Actually, the salt itself that we are going to dissolve. Most of the case, our solvent, which is the liquid, is normally water, distilled water in that case, because we'll be talking about add water somewhere. So this one is a topic of course, we'll be talking about ions that are present in add water. And distilled water is what you call now. Let me just use opposite of add and say soft water. So distilled water will be our solvent. The solute now will be the salt. Now, when there is a point yenye ukiwekanga hata, I'll use an example of something that we take, all of us. Maybe some of us don't take sugar anymore, but I'll use that example of sugar. So when you add sugar to tea, ukiongeza sukari, kuna time yenye inafika yenye I dissolve anymore. It does not dissolve anymore of that sugar or of that solute now. Ikifika hapo tunasemanga that particular liquid or that particular solution is saturated. It is at a particular temperature. Of course, we are very specific that temperature. Now, I don't know if you did factor that affecting solubility, but one of them is temperature. So at a particular temperature, we are specific because of increasing the temperature, especially in solids and liquids, will affect solubility. But when we talk about gases, it doesn't come in so much. But I think we'll see that one. So a saturated solution is a solution that cannot dissolve any more of the solid, which was now the solid, cannot dissolve any more of the sugar at a particular temperature. So, for example, if we are talking about our tea now, I would say a saturated tea is a solution that cannot dissolve any more sugar at a particular temperature. For example, 60 degrees Celsius or 60 Kelvin. Now, remember when you're doing calculations in chemistry, I'll still, because you are doing revision, cut across. When you're doing calculation, anytime there is a calculation and it involves temperature, you don't use degrees Celsius. You use Kelvin. Interconversion, I think it will be done later on. But if you have degrees Celsius, you add 273, just like that. Let me just convert. If you have degrees Celsius to Kelvin, you add 273. So it is plus 273. So a saturated solution is a solution that cannot dissolve any more solutes. That one is very okay. That means if you add any more solutes to that particular, if you add sugar to that particular tea, haiwezi dissolve, ina settle tu huko chini juu imefika saturation point. And most of the time, we do not normally consume saturated solution. The only time we are interested in saturated solution is when you are preparing a certain sauce. But we will see about that one later on. I think it will be there. Or if we didn't, I think we did it in Form 2 because I remember preparation of salts, but we'll talk about crystallization. We'll talk about crystallization. So, so at this point, if you add more solid, it will settle at the bottom of this. It will not dissolve anymore because there are no particles of the solvent that are free anymore. So all the particles of the solvent that were responsible for dissolving now imetumika. So zenye zinaingia haina effect tena, zinabaki hivyo hivyo. I hope that one is okay. Now, when we talk about saturated solution and temperature, we give the specific temperature because anytime we heat a saturated solution, it will dissolve. I normally ask students this way. Now, when you add sugar, you'll answer this one. I'm seeing op is in window, which is okay. You're welcome. So, I'll ask the two of you this way. When you have cold water kwa kikombe and hot water kwa kikombe. Now, and then you add 3 teaspoons and 3 teaspoons to the cold and the hot one. Which one will dissolve more? Which one can you add more and still is all of it is dissolved? The hot one or the cold one? And this one I think we did it. Yeah. So the hot one normally dissolves a lot. So that is why when you talk about solubility, we must give in the definition always the temperature is there. So you must tell us the temperature. So it should be at a particular temperature. So we can continue now. So you must know what saturated solution is. So we're saying the saturated solution is a solution that cannot take any more of the solid or the solutes now at a particular temperature. So the temperature is always there when you're talking about so what is solubility? So solubility actually is the maximum mass of a solid required to saturate 100 grams of solvent at a particular temperature. So I'm saying it is very important for us to talk about. Now, I will underline the most important things that you're supposed not to miss when you're giving the definition of the word solubility. The solubility of a solute in a solvent, so we are saying is, first of all, this one. Now, this normally brings confusion. Students normally tend to confuse this one, and there is this thing that we normally define in, is it ionization energy? Yeah, ionization energy in Form 2. So students normally tend to confuse maximum and the minimum. So actually ionization is the minimum energy. Without that minimum, you get the answer wrong. The same thing with solubility. So we're saying is the maximum much. So you are supposed to say maximum, that one is very important. And then to saturate, that means it can take no more. yani imetosheka. I think we normally say I can't take this anymore. So it is at that particular temperature, it can't take any other solid. So that solvent is certified. Inasema nimetosheka, sitaki ingine, that one now. So is the maximum mass of a solute required to saturate. So this one, now if you forget the word saturate, there is no problem. We have other alternatives. You say that cannot dissolve anymore solute. That one is still correct because we are saying saturation cannot dissolve anymore. So you can say is the maximum mass of a solute that cannot dissolve anymore solute. Yeah. So or that's now this one is very simple because it is short. The reason we normally choose this one is because it is shorter, so it is easy to remember. So is required to saturate 100 grams of the solvent at a particular temperature. So another thing that is, so I'm saying maximum is very important. It must be there for you to get the correct answer. Saturate must be there for you to get the correct answer. Remember, it is not 1,000 grams. It is 100 grams. We'll be talking about the specifics down. So it must be 100 grams. Actually, not 1,000 grams. So it must be 100 grams at a particular. So now somebody gave me the definition this way. I'll just give you because I know that one. Most probably you will also give that one. So you will say, is the maximum mass of a solute required to saturate 100 grams of a solvent at a constant temperature. Now, when you say constant temperature, it is still okay. So it is still very okay to say constant temperature because that one is at that time it is a constant temperature. So we say at a constant temperature or a particular temperature. Now, those things that are circled are very important. The only reason I circled 100 grams is because some people normally tend to give 1,000 grams, which is we don't talk about 1 kilogram of water. We are talking about 0.1 kilogram of water. So we go to 100 grams of water. Because now, so they'll ask you what is solubility. So I've already discussed that. So is the maximum mass of a solid in grams that will dissolve. Now, the units that we are using in this case is in grams. We'll talk about some calculations up chini. So you don't have to worry. You just have to get the idea of its definition. So is the maximum mass of a solid in grams that will dissolve in 100 grams of water at a particular temperature. So you can see we have said maximum. We have given maximum mass. We talk about maximum mass. We are talking about maximum that will saturate. So actually, it will be the one that will saturate. That will dissolve in mass of solid that dissolve in 100 grams. So when you talk about maximum, actually maximum, most of the time, the maximum is the one that will give you the saturation. Toko is the one that will give you saturation. So solubility of a solute in a solvent, we become very specific. When you talk about solubility, what we're interested in more is the 100 grams of water, the 100 grams. So we're interested in the 100 grams of water. So we're interested in these 100 grams and the particular temperature or at a certain temperature. Very important. Please mark that one down. Welcome. I'm seeing Maura is in. Welcome, Maura. We have not yet gone far. And I remember, I think this one is, we are repeating some part of it. So it is okay. So we continue. So I'm saying it is very important for you to remember what is in the solubility, the maximum. The mass that will be, the unit is grams. The mass of water will be in 100 grams. And of course, we are talking about the temperature should be very specific, a particular temperature. It is even better to be wrong this way. That one will be right at 100 degrees Celsius. That one you are saying all of this solute will be there. At that particular time, the solution will be at this 100 degrees. So you become very specific. Now, solubility. Actually, we have this one now is very, very dangerous. Most of the teachers never talk. We never teach the formula for getting solubility. We never. We are not normally interested in teaching that one, but it is very important, especially because the reason why we don't teach most of the time this one Is because most of the time we will be doing a graphical analysis. We are drawing a graph. Actually, we are not doing the calculation, but we have the formula for solubility. Na ndio hii sasa. We are going to do this one, and then we do an example. In fact, I'll give you, because we are only three, we can all of us solve, and then we see if we are getting the correct answer. Kila mtu na swali yake. You just have to say the answer is this. There is no problem, and then we can try. And you don't have to converse. Actually, we just say, or you can even do on the chat. You can do on the chat, or you can, if you want to converse, you just tell us how you did it. I'll mute myself so that we try, because this one also is very dangerous. I think this one was there in the KCSE, not last year, but I remember there was an exam that was there. That is why I brought in this one in my notes. I wanted people to know this one, it is possible to be done without using the graph. So you can continue. So we say solubility. I hope I'm not moving too fast. If you're moving too fast, please do say something so that we can train the pamoja. So this one is, let me just enclose it. So the solubility is equivalent to, now I want you to see the units that have been placed. The solubility over certain solute of sugar, because we're using sugar in our tea, is the volume, which is 100 centimeters cube. I want you to see this one. I normally write my units when I'm doing all my calculations. I write the units so that it can help me. It has idea somewhere. You will see. Now, so it is 100 centimeters cube. That one actually is the volume. Now, somebody can use this one in grams, because we should be given, most of the time we're given the density of water, and the density of water is actually 1 gram per centimeters cube. So if you convert this one, then you'll have no problem. There is no problem actually, because you'll get still 100 grams of the volume. So there's no problem. I think we'll see in an example. So you should not be worried. So you have 100 centimeters cube over the volume of water that you are given at that particular time, depending. So you can be given 10, you can be given 20, you can be given even 1,000. Multiply by the mass of the solute. And remember, the volume of the water is also in, I want you to see that one. It is in centimeters. The mass, we have said it is in grams. It is in grams. In fact, even in the definition, we are saying it is in grams. So this one is the, if you're writing it down, I think I had sent this note. I shared this note previously. Yeah? I shared it when we are dealing with the, I said people can go through them later on, but I had shared them. So if you're writing it down, this one is very important. Now, the unit of solubility is grams per 100 grams of water. It is grams, so we can say it is 10 grams per 100 grams of water. It is very specific. I know when you're dealing with ratios, we normally say we cancel out zeros if there are something that we make it to the simplest form. In ratios tunasemanga tunaiweka ikuwe in very simple ratios, simple values. That means if it is 5 to 100, you divide by 5, and then you divide the 100 divided by 5. I hope you get what I'm saying. Now in this one, both will be correct, but the better one is the one that has per 100 grams, because we're interested in per 100 grams. Yeah. Which is actually in the definition of solubility. Sijui kama tuko sawa. Now let's do an example. Let me wrap this one and then we do an example. And then you see what I meant, what is meant by what we are doing here. Or it better explains the formula. You will see in explain your formula better. Now, so let us proceed and we see an example that has been done. So we're saying calculate the solubility of potassium chlorate if 5 grams of the salt saturate 10 centimeters cube of water. Now, the density of water is given. Of course, it is all known that the density of water is 1 gram per centimeter cube. Now, a teacher that is very tricky, they normally give this one, wanaletanga ikuchanganye kidogo. If I was the one setting the question, I'll have given the density of water is equal to 1,000 kilogram per meter cube. So 1,000 kilogram per meter cube is actually equal to 1 gram per centimeter cube. I'm just giving you. Now, let me just write that one down for the sake of maybe being tested somewhere else. I don't know. I don't think there's somebody who's doing physics. I've never met physics students, so I can't say anything about. Do you have somebody who's doing physics in this class now? Do we? So I don't think anybody is doing physics, so it is okay. So sometimes, so 1,000 kilogram per meter cube is equal to. I will not explain that one now to you because you are not doing physics. So for those of us who are doing physics, I think this one will be explained better. So I'm just explaining just in case you're given 1,000 kilogram per meter cube, you should not be worried. They will say the density of water is 1,000 kilogram per meter cube. Usikuwe na wasiwasi, sema tu 1,000 kilogram per meter cube is equal to 1 gram per centimeter cube. This one actually is something that is calculated. It is correct. It is found. We can calculate and we still get it. So it is okay. So when you're given the density of water, I'm just explaining. Sometimes they give you the density of water, and then you are like, na sisi hatukuambiwa hiyo. So I'm telling you that if you're given a 1,000 kilogram per meter cube, it is equivalent to 1 gram. So usikuwe na wasiwasi, yeah? So there's no problem. Now let us continue now. So we continue and we say solubility is equal to, so we had said it is equal to 100 centimeters cube over the volume of water multiplied by the mass. So we have been given what? So we have been given 100 is a constant. Let me say that word. 100 centimeters is a constant. The volume of the water that was used is 10. So it is here. I was rubbing that one. So we have been given the volume of the water ndio hiyo. So the volume inakuja chini, which is here. 100 and then 100 is here also. And then you multiply by the mass that you have been given. Directly, you put it, multiply by 5 grams. Whatever you get now will be the answer in grams. So the answer you get is the unit, is the mass of the solid. Or now we are talking about, in our case, you don't say solid, it is the mass of the potassium chlorate. So it is the mass of, so it is 50 grams per 100 grams of water. I'll give you a minute. Let me just give you a minute to go through that one. Na muniambie kama iko sawa. Just a minute. Only a few minutes because time tulianza late sana. We came in like 20 minutes late. So that's why I could be moving a little bit faster. Just go through because we're going to do another example. I hope tuko sawa. Now, if you don't understand, it is better to ask now before we go to something else. Because I normally find it very hard to come back and explain when time mamioto zimetoka. You know, it is better now because you're still there. You know, when you understand something else, when you jumble up a lot of things, it brings issues. Now, so I'm hoping that you're okay. There's something that I had mentioned there, maneno ya ratios. Now, if we were dealing with ratios, what you would have done here is would have said by 1, this 0 and this 0 goes by 5, 1 by 10. So 5 divided by 10 divided by 5. 2. So it actually tungesema it is 1 gram per 2 grams of water. So nimesema hapa the definition of solubility is guiding us on the unit, so we don't cancel out. Do not cancel out. I think that is this one was I normally use I chose this question specifically so that I can tell people not to cancel out. Both this one actually is by 51, by 52, so it should be 1 gram per. But we are interested in in 100 grams. So we want this place. What we are interested in is we want to see the 100 grams. We want to see the 100 grams. Now, something else I'm supposed to tell you here is the reason we write units, the reason I normally advocate for students to write units is so that this one can happen. So we have 100 centimeters cube over the volume, and the volume, of course, should be in centimeters cube because of the, now we are being guided by the density of water. So the reason why I normally advocate for that is so that you can cancel out these two. One is, and then what remains now is the grams, and that gram is here. So you write the units so that in case you forget or you are too fast, you just cancel out the zinatoka. Sometimes time in a catch up on you, and you have to do it very quickly. That's what you do. I hope you're okay. Now, another example. Let us do one example. Let us do another example. So let me cancel that out, and then we continue. So we continue, and then we say calculate. Now, it is a different question, but the same thing. So sometimes how the question is tested or how the question comes out could be a little bit different, but it is okay. So saying calculate the solubility of potassium nitrate if 5 grams of the salt saturates 40 centimeters cube of water at 8. So this one, the temperatures has been set at 8 degrees. So that one is the saturation. So 5 grams saturates at, remember, we are saturating how many? 40 centimeters cube. But in our case, we don't want to saturate 40. We want to saturate what? 100. Because actually the definition of solubility, this question now is where we are supposed to explain very well. So 5 grams saturate 40. But we are not interested in 40. Did you come at what I'm saying? We are interested not in 40 centimeters cube or 40 grams of water. We are interested in 100 grams of what? Water. So that one is very important because of what we are getting, because of the unit of solubility. Actually, let me just go back a dog. The unit of solubility is grams. So grams per 100 grams. Hapo iko sawa. Now, so this one, they are saying calculate the solubility. So actually, you have been given. Let me write down. Let me write down. So we are saying 5 grams. Now, remember, I didn't give in this question because I'm the same person who was teaching both questions. So the density of water is normally 1 gram per centimeter cube. So that one, I didn't write it in this question because it was a class that I was continuing. Now, so the first thing, they're saying 5 grams saturates 40 centimeters cube. So you're supposed to bring that one into mass. You change the one. So we say 40 centimeters cube is the volume. So volume is equal to 40. Let me just explain this one. You'll do for me number 3. I'll require that you do question 3. We can all of us, one question, and then we have the same, we check if we are getting the same answer. So that will be okay. So volume is equal to 40. Let me just solve this one very slowly because this one will be a shortcut because I'm the only one, I normally teach it, so it becomes very easy. 40 centimeters cube. That one is volume of water. Now the density, I don't know, density was written this way, is equal to, density was a confused P, is a confused P, but let me just do it upper. So density, I'm moving very slowly because I'm not using a touch screen, I'm using the, actually, but there is no problem. So density, we have that one. So density is 1 gram. So I want to convert this one into, I want to show you how to convert because if we are not doing physics, now most of the physics students would easily understand how this one is coming to be. So we have volume, we have density, and then we have mass. And this one has a relationship. We have mass, and they have a relationship. And the relationship is done this way. Density is equal to, let me use mass because we are looking for mass. So we normally say mass, which is normally given by a small m, capital M, there is no problem, but I will understand that we are talking about mass is equal to density. Mass is normally equal to density multiplied by volume. So we multiply density by the volume. And these relationships, all of these ones now, you can manipulate to get volume. You can manipulate to get density. So there is no problem. It is very easy. You just manipulate. But the formula itself is mass is equal to density multiplied by the volume. I hope you're okay. So if I wanted the density, I'll say it is mass over volume. If I wanted the volume, I'll say it is mass over the density. So there is no problem. But in this case, ours we are looking for, we are interested actually in the mass. So what you do, you just replace. So we have 1 gram multiplied by 40. Where this one and this one's in end. If you can see very well, this was in a talk when you multiply the two. So the centimeters cube. So what we get now is the mass. Whatever remains is mass, that is why we are saying it is 40 grams. So 5 grams dissolves in 40 grams of water to saturation. Remember, the units of solubility is grams per 100. So what about 100? So hizi tumesema yenye tumepewa is not actually solubility. What is being given here is 5 grams per 40 grams. So, but we want grams per 100. So that is why inasema 5 grams dissolve in 40. What about 100 grams? And then you just cross multiply now. So this one you multiply with this one, and then the other one comes down. And you get this one. I want you to see what is happening. Please see what is happening. So you have 500 divided by 40, which you get now, it is 12.5 grams per 100 grams of water. And that one now is actually the solubility. The first one is not the solubility, because solubility units is gram per 100 grams. So we are looking to make this one certain mass per 100 grams. Let me rub mine so that you see what I have done. Because I wanted to explain some few things. I'll give you also a few seconds to go through as I rub, because I think the nature for, but I was explaining, I wanted people to understand. So let me just rub mine, and then you see. Are you seeing now the idea? The only thing that I wanted to explain is maybe conversion of the volume to mass, given that we have the density. So that one is very important. So actually now the solubility of potassium nitrate is here. Iko sawa mpaka hapo? Are you getting some light? Are you understanding this thing? Because now the next question I'm leaving it for you. I've not solved the second. I've not solved the third question. I want you to try. I want you to try. If you don't understand, and then we tunaingia wote we see what will happen. So we continue. Can you please? No, let us not do it kila mtu yake because of time. Wacha wote tufanye hii moja. The solubility of potassium chloride. That is potassium chloride, which this is the chemical name. Is 52 grams per 100 grams of water at 100 degrees. How much can dissolve in 40 grams of water at 100 degrees? Now, remember, when you're dealing with the definition, we say particular temperature. So you can check that the temperatures at 52 is the same, and the temperatures 52 grams and 40 grams, we use the same temperature. So there's no problem. So can you try? This one is very easy, actually. It's very easy. Can you try? Ebu mujaribu hata nyinyi. Let me just give you a few minutes. You try, alafu you tell me the answer so that I see. And then we solve together. We'll still solve together. So that one is okay, Monica, Wendo, and Mauro.
Yes, let us try.
Yeah, let us try this. Year number 3, and then I'll continue. I'm giving you how many minutes? Paka 9. So that means I'm giving you 3 minutes, and you are 3. So count off to me 1 minute, 1 minute, and then we see. I'm muting myself for the 3 minutes. Yes. I don't know. I think our minutes is done. So what is the answer actually? I don't know the answer. Hata mimi sijui. So we'll solve it all of us. So the solubility of potassium chloride is 52 grams per 100 grams of water at 100 degrees. How much can dissolve in 40 grams of water? Yeah. Na nasema when you're dealing with graphs, tukifanya na graph, it will be very easy. You just have to do a drawing. The graph, I'll show you. I think we'll solve the same question in the graph so that we'll level. So what is the answer? I don't know. I'll use the let me use venye imekuja kwa screen. So Monica is the first one, followed by Wendo, and then Maura is the last. You just give your answer. There's no problem whether it is correct or wrong. It is okay.
Mine is 76.9 grams.
So let me write. I'll write 76.
76.9 grams.
6.9. Hope Wendo.
74.7 grams.
70.
Oh,
74.7.
yes.
Okay, and then lastly Maura. Maura, umepata kitu. We just now actually all of these answers are correct first of all, especially when you're doing a graph. I'll show you in a graph why all of them are correct. So maybe when they give you a calculation, it could be wrong, but in a graph, kila mtu anapata correctly. So as we wait for Maura, I think I can continue. Okay. So I don't know where we solve, but I just have to solve it somewhere. So we have your answer 76.9, 74. Now the difference is plus or minus 2 actually when I'm marking the graph one. So if you're doing graphs, all of you will have scored correctly because now the difference, maybe I could get myself 75 in the graph. Na nyinyi mko na 76 na 74. So a graph, actually the answer of a graph, when they ask you in a graph, all answers are correct when they are nearer the correct answer because of it is a curve. We'll talk about curves later on. So a curve will depend on how the mind that you are drawing. Some of us are left-minded, so yako itaenda left kidogo. The other ones could be right-minded. So everybody will draw different. The graph. So both answers are correct. Now let's solve it this way. So you're saying 50 grams, 52, not 50. So you're saying 52 grams. So I've written the far end of 52 grams dissolves in 100 grams. So actually this one is something that you can do it. Of course, I do not have a calculator myself here. Now they're saying at 100, so the temperature is kept constant. So it is there's no problem at a particular. So it is this particular temperature is actually 100 degrees Celsius. How much can dissolve in 40 grams of water? So we have 40 grams of water. Remember, so this one is 52 grams of potassium chloride per 100 grams of water. So the 100 grams is water. Let me just use W for water. How much can dissolve in 40 grams of water? So the 40 grams of water should be here. 40 grams of water. Forty grams of water. So that one is actually it is very. So how much can dissolve? So we are saying how much. This is the question mark. How much of potassium? So potassium chloride nasema 52 ina dissolve in 100 grams, si ndio? So it is actually understanding the question that makes it very easy. So they say, how much can dissolve in 40 grams of water? So ni ngapi itadissolve kwa 40? So that is, you're saying now 5200. 40 grams of water ni ngapi? And then you cross multiply. They say this question ni kama hii. So you do this, huyu na huyu na huyu na huyu. So we have 52 multiplied by 40. So in a graph, it is very easy over 100. So I don't know which, no, it is 52 by 4. It's around, is it 200?
Inakuwa 20.8 grams.
20.8. So 20.8 grams per 40 grams. So actually, if you are given this question now, I want to explain this question. So it is 20. I don't know how you did it, but I know where the confusion came in. I think the 52 grams per 100 grams, and then you ukaweka 40 the other side. I think that is where the confusion came in.
Yes, mi nilifanya hivyo mwalimu. Instead niweke kwa
Yes.
100.
Yeah, so that is why now I wanted you to solve the one. So it is very important for you to understand it is 40 grams of water. So unasoma swali mpaka mwisho. On 40 grams of water. It's not actually, they're saying how much can dissolve. So they're saying how much. In fact, if it was a simpler question, kama si English, sasa wenye wanasema repeating words, I don't know, is wrong. I think Mother has been telling you this. They're saying, if you say now, how much of potassium chloride can dissolve in? So actually, tungesema how much of potassium chloride can dissolve in 40 grams of water? It would have been easier to understand than saying how much can dissolve. So this question number 2 and 3, let me say they are cousins. Hii ingine tulipewa yenye tunatafuta. You see the one that we are looking for? We have been given, we are saying 5 grams in 40 grams of water. And then they're asking the solubility. This one they have given us the solubility, they're saying go back now and do something different. So actually, anytime you see the amount of water has been reduced. Now let me explain it this way. Anytime you see they have reduced the amount of water from 100 grams, anytime you see 40 grams of water, 10 grams of water, anytime you see of water, and they have given you, you know that the value should be smaller than the yenye iko kwa 100 grams. Sijui kama mnaelewa tunasema? You understand what I'm saying?
Yes, yes.
Yes, wakisema wakireduce of water ikuje chini, that means they are saying 40 grams of water, the solubility ina reduce. Waki increase the of water ipite 100, waseme 300 grams of water, that the solubility again will increase. Yeah, the mass that will be dissolved also increases. I hope that one is okay. Yes. So we continue now. So I don't think we are going to do question number 4, but you can try. I had sent the questions. I think you have, no, I had sent these notes. I think I shared these notes previously. Kila mtu ako na hizi notes. Everybody has the notes?
Please, tunaweza tuma tena mwalimu, yes.
Oh yeah, I
Can
think
you
you're not
receive-
around.
Yeah.
Sorry? Okay, I'll
Can
reshare
you-
it in the group. I'll reshare it in the group. But in the meantime, let me just give you this one as your takeaway. You go and try. Ikikataa pia, you can ask me or you can ask Madam. This one. Try number 4. So I'll only, of course, in this recording now, people can still see. Yeah? So how much oxalic acid can saturate 25 grams of water at 20 degrees if the solubility of oxalic acid is 75 grams per 100 grams of water at 20 degrees. So this question actually, and the question that we solved, I think they're sisters. We can say they're cousins. So we solve it the same way. We don't use the formula. We just give the relationship. that we'll be using in moles. We give that relationship of. So this one you can try it later on. I'll still share that one. So there's no problem. Then we continue now. So you try that one. Question number 4. I think I still have some questions. I don't know. I think I had shared I still share the same things. I'd shared questions of all Form 4 topics. So I'll still share all the questions of Form 4 so that somebody, you try it, use it for revision purposes. And also, I'll advise you to use what do you call this book? Made Familiar. I think Made Familiar normally has very good questions, HSC questions. So it was idea pia. So that one is okay. So we go now to the factors affecting solubility. Factors affecting solubility. We have 2 main factors that affect solubility. But I wish we could be having a session, a lab session, so that these ones are very easy to explain when you are seeing it. Actually, when I'm using a Bunsen burner on this side and a cold one on this side, and I'm adding some solids, and so you will see without even stirring, which is also one of the factors. So temperature. So temperature, obviously, solubility increases with increase in temperature. So they are directly, as you increase the temperature, the solubility is also increasing. So of course, this one is the explanation where we talk about the kinetic energy, that is the movement of particles. So disintegration now increases because of the kinetic energy actually is movement of particles. So when you talk about movement, we are talking about momentum. That is why I don't want to explain into deep, but I wanted to tell you that solubility increases with increase in temperature. These factors, we will still talk about them somewhere. I think it is in rates of reaction. In rates of reaction, we'll bring them back again. And then I think it will be explained better in rates of reaction. I think rates of reaction, which is the second topic. I think it's the second topic of Form 4, rates of reaction. I think those second, the third. So there's no problem. Now, this one is for solids and liquids. I remember I had mentioned somewhere that in gases, solubility is not affecting the temperature. Reason being, the distance between gas molecules. When we talk about the states of matter, I don't know, did we talk it? I think it is in Form 1. When you talk about now the distance of gases in states of matter, tunasemanga solids na liquids zimekaribiana. But when you go to the gases, ziko mbalimbali. I don't know if you remember those things. So those ones now, if you increase the temperature, that means you're increasing the distance. Now ilikuwa na distance already. So that means it affects the solubility. So that is why now we are saying it decreases with increase in temperature. That one is for the gases. So temperature affects only for most salts, which most salts actually are solids. So for solids, increase temperature increases solubility. Gases, the opposite, because of the already distant molecules of gases. So they are far much apart than those ones in solids and liquids. So that one. Number 2 factor is stirring. And in solids, normally increases because stirring, what we normally do. Everybody has done stirring. 100% sure. Stirring actually is ile maneno unaweka sukari kwa kikombe and then ndo ukunywe haraka, what do you do? Unaweka kijiko na unakoroga. Stirring is kukoroga. Let me just say stirring is kukoroga. So it increases solubility because what you are doing is you are causing the molecules to move faster. You are increasing the kinetic energy, and kinetic energy means more interaction. More interaction with water molecules or the T molecules. So effective disintegration. So stirring ni kukoroga. Stirring increases solubility. I hope that one is okay. So I could ask this one this way. Ukiweka sukari kwa chai na usistire, what happens? Does it dissolve? Will the sugar dissolve usipokoroga na kijiko? Does it dissolve?
No.
Yeah. So
Itadissolve
that one is
kidogo.
yeah, kidogo. So we're saying it is a factor. So if you stir, you increase. If you do not stir, you reduce. Yeah, I hope you're okay. So temperature and stirring, I don't think anybody will ever forget that one. The only problem is forgetting the word stirring. I think that is where the problem will come in. But temperature, in fact, since we are all ladies that are inside now, I'm not being biased. I'm a gentleman, so I know. I hope I'm not being biased. Most of us, when we are cooking at home, especially I normally use tea because it is something that is an African delicacy. Yeah? So Africans without tea, I think what one is my vicho in our home. So let me just use something that everybody uses. Without tea, if you want to take tea in the morning and you cook uh na moto ikaisha, let me just say moto ikaisha, or let us say you're using a gas na ikaisha before ichemuke vizuri. Do Africans really take that tea? Does it taste like tea? Utafurahia hiyo chai.
Haijaiva vizuri.
Exactly. So you do not forget temperature and usisahau nini? Maneno ya stirring. Please do some. So actually that one is solubility. In summary, that is solubility. You have so the most important thing about this one, about this before I go to the carbs, the most important things I'll use the same example in the other one so that you see the same example that is number 3 when you're doing the carbs, so that you see when you talk about solubility, please do not forget the definition of solubility. That is number 1, very important. Grams per 100 grams specific temperature. I've given actually the summary. Now, ukishamaliza hiyo, you have the formula. That is the formula of calculating solubility without using a graph, because sometimes the question can come that way, and then you not be able to draw a graph. So hiyo a formula, I will now calculate and how to solve equations that are related to solubility, which we have done. Now, something that is not supposed to forget is the factors affecting solubility, and I'm saying these factors now. Temperature is very dangerous. Reason being, they'll tell you what if we increase the temperature when you are reacting sulfur oxide and oxygen, what will happen? Most of you will, maybe because of hurry and understanding that temperature affects solubility this way, you will shout or you will write very quickly that temperature increases solubility. But I've said for gases, it is the opposite. Actually, temperature does not increase what? Solubility of gases. It is the other way around. Now, tuko sawa mpaka hapo. So we go to solubility curve. From the term solubility curve, it is a curve. It is not a graph. It is not a straight line. You don't use a ruler drawing the graph inside. The only time you use a ruler when you're doing this graph is when you're dealing the axis. Yeah, ukichora x-axis na y-axis. That is the only time that you use a ruler. After hapo, unawachana na ruler. You use now your free hand. I will be talking about how we do the graph. So because the graphs, I normally say graphs in chemistry is very important because you can forget everything, all the theory, but drawing a graph, I normally say, is one of the easiest part of it. Now, most of the time, we don't have graphs in paper 3 in chem is normally few. Sio rahisi yani wakupe graph kwa paper 3. But I'm not saying it is not possible. I'm saying it is not the probability of it coming in paper 3, I don't know, is not very high as it coming in paper 1 and 2. So it will come in paper 1 and paper 2 more oftenly than when it comes in paper 3 because of quantitative and qualitative analysis. So because of quantitative and qualitative, that one is an issue. So the amount of solute which dissolves in a solvent, e.g. water, in a particular temperature is different for different substances. Of course, you are talking about that one. Solubility of different salts is different at particular temperature. So each temperature affects solubility of each solute, which is now the salt at that case, different. So how do we show that there is variation? We show variation by using what we call the solubility curves. Nimesema there is a reason it is called solubility curve and not solubility graph. It is solubility curve because it is a curve actually. And a curve, you don't require what? Curve, you don't require a ruler. A curve, you don't require a ruler. Let's do the curve. Now, a graph of solubility of solids, that is of solubility of a salt in grams per 100 grams against, I'll just explain that one using this one. Against the temperature shows variation of solubility with temperature is called solubility curve. So the solubility curve actually is the graph that will show. Now, let me just solubility curves. Now, when you talk about a solubility curve of solubility of salt in, I'll explain this way, the way I normally explain. I always want people to understand the graph. It is solubility. So they are saying we'll be dealing with that one. So solubility curves for different solids. For different solids, I'm not interested in that one. I'm interested in this one. So we have A. This one is A. So we are saying plot a graph of A, which is solubility of salt, any salt, yeah? Solubility of A. So we are saying this one is A ya kwanza yenye imeanziwa kwa question. So the same solubility of A, this corner, naona hii corner, this end, kwangu naitanga against. When you're doing graph, this one is called against. So plot the graph of solubility of, for example, of solute A against temperature. So hii corner, hii corner, in the against. That one is against. So anytime you see plot a graph of against in all the subjects, bio A hii corner ikuwe against. So yenye inakuja chini ni B against temperature. B A against corner, hiyo corner ikuwe against B. Hapo tuko sawa, because the graph is normally very dangerous everywhere. Anyway, whether you hata kwa hesabu unatumia the same criteria, A against hiyo corner ikuwe against B. Something else you're supposed to know in graphs, please name the axis. So we have the Y. This one I think is the Y. This is the Y axis, Y and X. And X axis. So una name, that means in solubility of a salt grams per. Those are the units, in units of solubility. So that one is okay. So the temperature. Now I didn't label for temperature because sometimes they give you in degrees Celsius and Kelvin. So hapa unaandika degrees Celsius or in Kelvin, depending on what you are given. So but most important thing is Y against, that is A against, hiyo corner ikuwe against na B. I hope tumeelewa graphs because I'll leave you with some questions. Of course, I'll send you some questions again so that you try. Mumeelewa hiyo maneno ya graphs. So these ones actually are curves, as you can see. So ndio hii inaenda hivi ni curve. There is no, as you can see, hata nataka muone venye mimi nilichora. Nataka uone potassium chloride. Let us go to, so this one is I want us to go to this one. Hii graph ya hii. Now hii potassium and sodium chloride. Did I use a ruler? I want you to see kama imetumika ruler. It looks like a straight line, yeah? But did I use a ruler? Is it a ruler? Can somebody tell if it is a ruler or not?
It is not a ruler.
It is not a ruler because it is what I want you to see. It is a curve. This one is, I think this one is the only graph that you're allowed to use your free hand actually plotting inside, plotting the curve. This one is the only one. So it is not a ruler. Don't use a ruler inside. Tumia ruler wapi? Nje. Especially doing the axis. This one na hii ya chini. That is the only time I think you're allowed to use a ruler in this case. Again, something that I'm supposed to tell you, that goes, you're never supposed to use a pen when you're doing a graph. So mtu akiona kalamu, which is the biro, mtu akiona biro while you are drawing, you are wrong automatically. You are wrong. Yani hata simark your graph using a pen, not a pencil. You are wrong. You become wrong. So for now, those ones is for solids. For gases, as you can see, for gases now it is opposite. Monica,
Teacher, I have a
want to say
question.
something?
Yeah,
Please
I have
do
a
ask.
question.
Yes.
Na what if ukitumia a pen outside the graph uko kwa y na x, mfano uandike temperature with a pen na maybe the solubility with a pen, is it wrong pia?
No, that one now is better. Yeah, I want to answer you. Yeah. So when you are drawing a graph, now the only problem I have with using a pen, maybe writing here, that is what you're asking. Monica, you're saying ukiandika solubility hapa na temperature hapa.
Yeah,
Now,
with a pen.
yes, that one actually is normally okay. The only downfall for that one is you get maybe the marker is a drunkard na marker amesema yeye, unajua kwa rules, when you're marking exam, the rule there is if you see a pen, it becomes wrong. Yeah, so the downfall now comes in, mtu ameshika amesema amesoma tu you use a pen na aone umeandika na pen, and then he gives you, he can deny you even a mark. Of course you will be correct, but he might deny you a mark saying that you use a pen. So I normally say it is okay to use a pen because of your idea ya labda itafutika. I don't know, the pencil can grab easily,
Kwa hivyo
but
so
I
you
will let
can
by the yeah, let us use a pencil all through.
all through.
Yeah, tutumie tu pencil all through because of some teachers, sisi tuna some teachers are drunkards. So labda ameenda kama amekunywa vitu zake kumark exam na asome rule kwa marking hapo, do not, if you see a pen somewhere it becomes wrong, so you lose marks, not because you are wrong but because somebody alikuja kama ako under influence. You see that one? So let us just use a pencil everywhere.
Okay,
Yes?
even the title, so we should use the
Yeah,
pencil.
yeah, we just use a pencil, and we have those pencils that are very good, the HB.
Yeah.
I think that one haivutiki. If ingekuwa inarambika, then we lose our graph again, the curve itself. So let us just use a pencil for the sake of, and now we have some people were complaining the other time from this class. They were saying, I don't know, maybe the marking during the first session we were talking about maybe your disadvantage in the marking. I don't know if it is true myself. I don't know. But I don't know. I had to ask a friend of mine. I don't mark chemistry. I mark physics. So I was asking my friend, were they affected? I've not been going for marking for a while now. So I was asking my friend, wanakuwa affected? And then she told me, no. We don't even know who they are. No, unless they are known. And the thing they don't know, they normally cover wanararua karatasi these days. Yeah, wanararua. So what they are using to identify that this student, what do you call? Scan code. Those codes. Kama ile ya, I'll use a very easy example ya connect sender. Is it sender? Ya connect sender. So ukitumia una scan the other person's code. Now they are scanning so that they know everybody has that code, unique code for each student. So that is how they know that it is, for example, it is Hope and not Monica, or it is Monica and not Maura. That's how they know. So I don't know, but for the sake of being fair, let us just use a pencil. Most of the time, by the way, okay, let me just say, let us write the title for the graph. But the title for the graph is normally affects two subjects. Sana. I think it affects bio and mathematics most of the time. But let us just do it for, unajua nikisema usiandike hii you might also end up leaving it in biology. And for biology, I add it is very important. I don't know. I didn't take biology in high school, so I don't know. I don't even have an idea. A lot of information about that. So solubility in gases, as you can. Yes,
Teacher,
yes,
for
yes,
the
Mauro.
title. Teacher, for the title, are we still supposed to use a pencil for the
Yeah,
title?
yeah, I'm advocating for all of us. Let us use a pencil in all the graph, which is better. For the sake of,
Okay.
I was explaining using somebody who is maybe amekunywa kitu yake kidogo now, and the rules are say actually we have rules when you're marking. The rules say if you see a pen, you give it wrong. So labda ule mwingine ameona pen huko juu lakini hukutumia ndani, and it affects your results for nothing. So why don't we just use a pencil? Kwa hiyo graph paper yote that you are given, just write using a pencil, use a ruler when you're underlying the title, and use a ruler, of course, when you're doing the axis. That is for solubility curves. When you go to other graphs now, for example, the one that has volume and temperature, when you're dealing with gas flows, please, we are drawing that one with a ruler. Sijui kama tunaelewana. It is only exceptional for the curves we use a freehand. But the rest now of the graph, actually they are considered as graphs, not curves, except for when you're talking about for source, which is solubility. Because so let us use a pencil all through. And we have those good pencils, so use a good pencil. And the good thing is marking does not go beyond 1 month after the completion of the exam. So before he answers Kufutika, they have already marked the exam, actually. And the results have already been handed over. So we use a pencil everywhere so that, and when they are marking, people marking go after money, they're after money. So the faster you finish, the more money you get. Yeah. So if you mark few, you get little money. If you mark more, you get more money. So what I will do, nikiona tu kalamu anywhere, mimi, a pen, then I mark you wrong. Why would I go through something and the rules are protecting me, saying using a pen is wrong, using a pencil is correct. So so it is better to be safe than sorry. Yeah, that is what I'm saying. Okay. So when you go to solubility, when you talk about gases, you can see the temperature is affecting it in the opposite direction. When you talk about solids, inaenda hivi. So it is A, I'm still going to repeat, A, corner, equal against B, which is the temperature most of the time. So tuko sawa. So NB, of course, solubility of gases decreases with increase in temperature. That one we had mentioned, based on the distances. We are talking about the states of matter. So when we talk about the states of matter, that one. Now, so you have to determine the solubility of something, you plot a curve procedure. So you're provided, we can do this one very quickly. I don't even have to read. I think you still, kila mtu anaweza ona screen. Now I've been sharing. I hope everybody can still see the screen. So let me check. Okay, nobody has mentioned anything, so we continue. So you're provided with 5 grams of oxalic acid. Actually, this one can be done in the practical, So inaweza kuja kama swali in the practical. And ikikuja, you shouldn't be worried. Unaweka tu venye you follow the procedure. There was an exam, I don't know, was it 2018 or 2019? And the students were not given the procedure. So you are told to write the procedure. You are given this and this, and you're told write the procedure of how you will do that one. I think this one is very common in bio. I don't know who tested that chemistry paper that year. Hakuweka procedure, so ulikuwa unapaswa kujiandikia procedure, and then you perform the practical, which was very tough. It was very tough. But when you're given the procedure, it is very easy. So you are supposed, and then you record. So you fill the period. So the procedure, there is no problem. You are provided for. It is taken care of. If they don't give the values, they'll give you the procedure of getting the values. So you do that, and then you feel now temperature will the crystals appear. This one is done actually in the practical. That's why I was saying if we get a session, I don't know, I put up in Eldoret myself. So I don't, if somebody is around, I think I can invite them to my school. We solve we do a practical together. For those who are around, we can do the practicals together. Now, for those who are distant, we had discussed, we said what one is the end. If we have a teacher inside us, within us, that can help you in the practical, the better. Unaenda tu, he just asks the principal for permission that we'll be having an extra student in that class, and then we do the practical together as students. So it will depend. For those who are, if you're around, I think I can help. Because I know some of us put up in Nairobi. Nairobi is quite far. Nakuru also is quite far, but we can still organize for you to get a practical session, which will be better. So you will get values. So the temperature that the crystals first appears, solubility, grams, so that one you can still calculate. And then now you plot a graph of, so the graph, I'm interested in the graph, actually, because the procedure is very easy. I'll give you a question that has values, and then we see if we can plot. So we have plot a graph of solubility. So I'll try to do that. Yeah. So that you understand what I've been talking about. Sorry. So plot a graph of solubility against temperature. So we are saying solubility. So we have solubility happening against temperature. So this corner is against temperature. Now, the first thing that we are supposed to do, know that the scale of your graph is alpha mark, and that alpha mark is normally given this way. If you use 3/4 of the page of that graph paper, or on that graph page, let me say graph page, if you use 3/4 of that graph page, you score this one automatically. Whether the graph is correct or wrong, this one you have it. If you use the scale that will cover at least 3/4 of the page, you get the alpha mark automatically. That means hata kama graph inapaswa kwenda hivi na wewe umechora hivi na imecover 3/4 of the page, I'll give you a alpha mark for using a correct scale. Now, labeling of the axis comes this way. So I'll give you alpha mark if you have written solubility on this side. So you have solubility, and then you have the temperature here. If you label that way, I'll give you automatically the alpha mark for labeling the axis. Sometimes even we are very lenient that we give you the alpha mark whether umeweka temperature hapa, temperature iko hapa na solubility iko hapa, which is wrong, but you have labeled them correct. So actually umechora lakini umekuwa confused where you are saying solubility against temperature. So ukaamua temperature ikuja hapa against solubility, I'll still give you a half a mark for labeling them wrongly. So you have labeled, but you have labeled them wrongly. But I'm going to repeat again. Anytime you see A, for example, this A against B, equal A equal E side. So we have A against equal corner equal against B. That one is very important. And then you plot the curve. Plotting the curve now. Sometimes you plot the curve, but you are wrong. You have used wrong values, but you have plotted the curve correctly. I'll still give you a mark. Now, the curve, how it is trending now. Have you followed actually what you have answered here? Now, that is where now we go now. You can lose easily that mark. Now, marks that are very easy to lose here are actually the scale and the curve trend. So it should be smooth. Later on, you'll score plotting. That is putting the x's, your x. And I'm saying, let me just go back to plotting kidogo. When you are plotting, you don't use dots. Don't use these on dots. Use the x. Weka x. Don't use and please, in a curve, in a graph, don't force the value. Kama umepata yako when you're doing the experiment ikakaa hivi na ingine iko hapa, usilazimisha ati ndo ikuwe straight line ati kuja ikaribiana hapa. No, just plot it correctly. Kama inakuja hapa, hata kama ingine iko huku, wewe weka tu. I'll give you the correct. For plotting the correct values is better than actually manipulating the values. unaweka. I think we'll do an example on that graph. Now let me wrap this one. I hope hapo tumeelewa kidogo, because now it is very easy when we plot a graph for this one than explaining. I don't know. I find it very easy when you plot it actually. So and then it adds up to 3 marks. Now in physics, the graph normally go for a little bit more higher than this one, which is 5 marks. I don't know why chemistry inakuwa kidogo. So it normally goes for, but I think for this one it is because you still have some questions to answer. So like for this one, so you have labeled this, so this one is solubility, and then it is in grams per 100 grams. You have the temperature in degrees Celsius, and then now you plot the graph. And I'm telling you, it is not a must for us for all the points to conjoin. Yani sio lazima ipitie points zote. As you can see, hata hii ijapitia vizuri, hii ijapitia vizuri, hii imepitia na hii, but hii imekaribia sana na hii sana, and also this one is near. So because it is an experiment, and an experiment has errors. Now, if it was a computer experiment, that means you do it online, the values will cut across by the way, itapitia zote correctly. But because it is being done by human beings, we still have an error. And this one now is a better, this one is better, better graph than most people would think. This one is a very good graph, being that ilifanywa na mwanadamu, na mwanadamu ako na errors, and the errors is taken care of by putting the graph such as it passes through the middle, so inapitia katikati ya hizi na hizi, so it covers for everything. Otherwise somebody else would have done this, ipitia hapa chini. The same person is correct actually, both of you are correct, so kila mtu ako correct. You see now what happens, so all of you will be correct, but the other one will be given better, the other one is better awarded. Yes. So unless you have a query, now something else I'm supposed to tell you, please extrapolate your graph. I don't know if you have ever been told, this one I left it out intentionally so that I can tell people to extrapolate. So mine is wrong because nimeacha graph hanging. The graph actually should not be hanging. How do we extrapolate our graph is we do this. You don't change now the curve. Tunaona ilikuwa inakuja ni kama inataka kwenda hivyo, iendeleze tu hivyo. Extrapolate, but don't turn the graph. Somebody else will make sure anataka ikuje hivi, which is wrong. In fact, if I wanted to extrapolate this graph, I would have done this now. Let me just show you. You don't leave that graph hanging. Usiwache hanging, hata kama haikuanzia 0, 0 in either of the axes. You just make sure that it is touching somewhere. And for this one, it will be easier for it to touch the y-axis rather than, so una extrapolate if what. Now mine could be having an error because of I'm using the cursor to draw. Otherwise you extrapolate ishike pahali, ishikilie isikwe, inaweza kuanguka. If it was a graph that was going this way, ikuje ni kama inashika ishike hiyo. Yeah, that way. So you plot a graph so that it is making sense. It is making sense. I hope that one is okay. You draw a graph that. Yes, Monica.
A question. Sometimes
Please
in biology, in
Yes.
biology or maths, sometimes we are given a scale, like a certain scale, maybe tumeambiwa tutumie scale ya maybe 2 centimeter representing 1 unit. In chemistry, are we given ama tunajitafutia sisi wenyewe?
Yes, in chemistry most of the times, and this applies also to physics. Most of the times we don't give a scale. We just give you a graph paper. So you look for a scale that will actually look for a scale. I think it is dangerous for me to be given. That is my point of view is, I think mimi nitasikia vibaya nikipewa scale than when you are not given the scale. That is from my case. But in chemistry, you don't give out scales. You choose for yourself a scale. Yeah, most of the time you choose for yourself a scale.
Okay.
Which I think it is better. It is easier to look for a scale that will fit you when you're unataka. And remember, when you're choosing a scale, make sure that it covers 3/4 of the page. I don't know. I think you are told that one in Hesabu also in biology.
Yes.
Yeah. Make sure that it's which You use the values. Now, when you choose, let me just guide you on how to choose the scale using let me just feel, I don't know if I have a question down here. Let me check if I have a question. I can't remember. Let me check. And this one is not completed. This one is not completed. This one is not completed. But let me just use this one. For example, you are been given volume of, so if you have the temperature starting from, let me just feel it carelessly. Yeah? Don't mind. I'll just feel it carelessly. So this one is, for example, 10, 20, 30, 60, 80. And then we have the solubility. Let me just choose anything randomly. 13, because it as the temperature increases, of course solubility increases. So we can start from 13. Sorry. This one again is image Michigan. The cursor has a problem. When you use, I think it is better to use. So you can have 15, 20, and now the solubility will be uneven. Of course, we can have 40, 70, 65, and then we have even 90. So we have this one. So when you're doing a graph, how you choose the graph, especially for the, now the good thing about now choosing your own graph is you can use a different graph for the x-axis and the y-axis. So there's no problem. So you make sure that the value that you get, the highest, the least value should be 0. Of course, when you're doing a graph, inaanzia 0. So 0 hata inaanzia 0. Now you count the number of squares in the graph. Of course, when you have a graph now, it becomes very easy. You can count, and then you know that the least is 0. The highest should be about ukifika huko juu ikuwe 90 for this case. Unahesabu, and then you say from 0 to 90 is how many? That is about 90. 90 values. So you divide the squares. You have those squares that are 10. You say that one I need 10. So if it is 12, I think ukijaza 10, it will be taken care of. Sometimes they give you the bigger one. So that means you will skip now larger squares. So you skip 10 and 10 for 0 to 10. That's how you choose that graph. For mathematics, when you're given, I don't know, I find it that sometimes in biology they require you to break. So instead of doing this, let me just draw for you. Una break hapa kidogo, alafu una break hapa pia. I don't know if that one is still allowed. I was told by, is this allowed? Where instead of starting from now 0 to 10, 20, ni 0,
Yeah.
alafu hapa ikuwe 40. Yeah, that one now is the only problem with bio. I don't know. I think this one is a little bit complicated because you want to make sure that you may cover 40, 3/4 of the page. So una break pahali, which I normally think it is very dangerous for students. Very dangerous if you are not very keen. It is a very serious offense kupoteza hiyo marks because of not breaking. Some of us wanaweza chora na tusahau kubreak huko chini na uanzie 40 to 60 or 40, 50 after breaking. Yeah. So this one, it is very easy to identify. So choosing a scale in chemistry and physics, you don't give out a scale. You choose for yourself a scale. And the scale should cover at least 3/4. So how you choose, you do 0 to 90, and then you divide now the number of spaces and make sure that it is covering 3/4 of the page. Now, when you're drawing a graph, I normally advise students this way. Kama unaona scale imekulemea, the first thing you do, so you know those squares, hapa wachana na kuna space ya white, wachana na the white space. We want the graph to be inside the graph paper. So if this one is the white page, alafu hizo boxes zinaanzia hapo, the boxes sasa. So I normally tell them, kama imekulemea kabisa kuunda scale yenye itakava 3/4 of the page, ingia, draw the graph inside, wachana na the white page hapa. So uchore graph hapa ndani. For example, you skip 2 lines, two of the spaces, that means 10. Unawacha 10 boxes, those tiny boxes unaacha 10 hapa, na uache 10 tiny boxes here for labeling. So you want the graph to be inside. So solubility unalabelia hapa na temperature unalabelia ndani ya hiyo graph. And then now, so that the graph can be, you maximize the space. Unatumia most part of it. So actually we'll say graph yako iko ndani ya, even the labeling is inside the graph, which is okay. I don't know if you understand what I'm saying. Ama nimeongea sana.
Tunaelewa, tunakuelewa.
Yes. So it is very, so choosing the scale in chem and chem values, most of the chem values make sense when you're plotting a graph. It is very easy. I'll share still. I want to share. I'll share some questions. I will want us to try one of the questions. I look for those questions right now as we continue. So plotting a graph, and these graphs are very simple. Like I've said, we plot a graph of solubility against. So the graph of A solubility against that one, the equal hivyo tu. So there is no problem. So the graph, so like I had mentioned, so how we mark this one? So this one has been labeled solubility. Of course, the units must be there, grams per 100 grams of water, temperature in Kelvin or in degrees Celsius. So we have labeling of the axes. You have one, half a mark, both of them. If you label one, most probably you will not score because we cannot give you a quarter. We cannot give you a quarter. So we have a sketching of the curve. No, scale. This one is the scale. Now I'm looking for some. Now, let me just finish this one first, and then I look for that question. I was looking for it in my phone, but there's no problem. So we have the scale. We have half a mark, which is okay. So you choose a scale that will cover at least 3/4 of the page. You have the plotting. The plotting now is this axis. Na nimesema tafadhali msitumie dot. Don't use a full stop. Let me just say, don't use a full stop inside the graph. Just use an X. X is better. And then you do the curve now, which this one now. And the curve should be of, I don't know, we normally say line of best fit. Line of best fit ipitie tu, sio lazima, usilazimishe ikunjane hii kitu ikuje hivi na hivi. Just make it a smooth curve. Smooth curve is drawn by not removing the pencil from the paper, from the graph paper. So ukishaanza huko chini iende tu, ukitoa ukiinua mkono na urudishe, it will be seen. It shows, by the way, it is identified like I have done here. Unaona yangu nilishikilia tu na ikaenda. And mine, imagine, is a pen. I was using a pen. So if you are using a pencil and you mess up, you just rub it. That is why it is better to use a pencil. So let us finish. I hope you understood my graph. I will require you to put, I hope you have graph books or graph papers at home. We will be required to at least plot one. Ukituchore hata moja tu. I'm saying I'm sharing a lot of questions. So users, now what was that the users? Not users. Users and importance is the same thing. Significance. Yeah. The word came. What is the significance of solubility curves? Significance, importance, users, all the same thing. So solubility curves are normally used to predict whether a reaction will occur. And now the only problem in when you talk about reaction, when you talk about reaction, students normally tend to say reaction is when you combine two things and then there's something. Actually, a reaction is whether it is coming the other way around, opposite, where we are producing something. That one is a reaction. Whether we are producing a product or we are producing a reaction. So a reaction can go either way, in either forward or backward direction. So solubility curves is used to predict whether we would have we do have solids or we would form crystals. That is solid. We will form a solid. Now it's also now what we use in what we call fractional crystallization. And I want to say this one very clearly: fractional crystallization and fractional distillation is something different but related. Both of them utilizes temperature. So that is the relationship. Both of them inatumia fractional distillation ile of liquefied air. I don't know if you remember where we are preparing oxygen, nitrogen, and is it argon? Where we have -183, -186, -196. Mnakumbuka hiyo story? Which is normally fractional distillation. This one is fractional crystal. So we are making crystals. So that one is normally used. So there are very many examples, but we are not going to do examples. There's a reason why I'm not going to do examples, because if I do this one, they will have problems. So fractional, I want us to see fractional crystallization kidogo, but we'll have to do it again. Is the process in which solutes are separated from each other according to the solubilities in the same solvent. Now, when we talk about solubilities, remember it is at a particular temperature where we have mass per 100 grams of water. So it is mass per 100 grams of water. So those ones are some of. Just wanted you to see this one, but I'm not going to do. I'm not going to do. I'll just solubility terms. We are not going to do any example because of time. But I want us to start from there when we meet. I wanted to show you something. I want to show you. Let me try if I can get those things. Just a few minutes, because you're already going with 2 or 3 minutes. I know you have another class at 10:30, so I want to keep you as you do something else, and then you prepare for the next class. I am stopping to sharing the screen. I stop to share the screen, and then I look for a question you see. For the name of those questions that I'll share, it is a lot of questions. I wanted to show something, and then we leave for that class for today, and then we meet another time. Let me check the name. Yeah. F4. This one. Yeah, I think it is this one. Let me check. Yeah. This one. It is this one, actually. So these ones are the questions that we are going to. We have not done some of them. So acid business source. So define the term acid. I think those ones we can, but I'll share the full question. Now, so we have below is a table. That is question number 10. I hope everybody can see that. Sometimes it's on. So below is a table showing solubilities of salts Q and R. These are now fractional crystallization. Now, that is, we are separating salts that are in the same solvent. So different solutes, then you will say, define the term solubility of salts. That is number 1. If both salts Q and R are present in what will be the total mass of formed in? That is how you are calculating those ones. So you do that one. So I don't know. I wanted us to do one question, which is easier. So I want us to do question number 12. I think if you can screenshot, I think let us screenshot and then we do question number 12. Na mtanikumbusha tufanye during the next lesson. Question number 12. Solubility. Yeah. So we do question number 12. Please let us do question number 12. I'll also take a photograph and then I share it to the, I don't know. Let me share it to the group so that you try that one. Please try question number 12, including drawing of the only question 12. So I'm going to take the picture of I've taken a picture of the same, then I share it on the group. Iko sawa?
Mwalimu, kwangu mimi sioni chochote kwangu, kwa screen yangu inaonyesha tu hiyo nini. I don't know what's the problem.
Is somebody else with the same problem? Now, what I do, Monica, it is okay. It is easy.
Yes, teacher, we can only see the topics.
Oh, sorry. Let me stop sharing. I'll stop sharing and then I share it again. Yes, no problem. But I've shared it in the... Now, how about now?
Iko sawa sasa.
Yeah, but I've shared it on the wall. I don't know if you can see it on the wall. Post kwa wall here, private student. Let us do question number. The reason why I wanted this one is because it has a graph. I wanted something that has a graph only before we go to fractional crystallization. So I'm saying question 12 is what is meant by the solubility of salts. Calculate the thing that we have done. Plot a curve for a salt X solubility. And then this one they have given you y-axis and temperature on the x-axis. What is meant by the points plotted in one above? So I think we can do that one. Two areas where knowledge of solubility curves is applied. I think we can do that on another time. Yeah?
Yes.
But I'm interested in the graph. Please plot the graph and then you answer some of the questions. Siko sawa?
Sawa mwalimu.
Yeah, I'll still share all of the questions and then I'll share the questions also and I'll share the questions and the notes. So that one is okay. I'll share the questions and the notes. For now, let me wish you the best. Have a very nice day. I think you have another lesson later on. So, and I've already eaten into the lesson, into using some of your time. So you have a very nice day and have a very beautiful weekend. Bye bye.
Mwalimu, mtu akifanya naweza kutumia.
Yes, please share it privately. You can just send it to my inbox. Unaweza fanya na unapiga picha na unitumie kwa through my number. Then my number ndo nimeshare tu hapo. The one I'm using to share that question. Yes.
Okay. Good day.
Okay. Good day.
Thank you.
Thank you very much. And you have a very nice day.